Consider the situation shown in the given figure below. Both the pulleys and the spring are light and all the surfaces are frictionless. Find the acceleration of the mass capital M. Find the tension in the spring. Calculate the force exerted by the clamp on the pulley A in the figure. So we are asked the following question for this particular problem. So let us begin by establishing a constraint relation between the two masses. So if I consider that this mass is going to move from here to here, and if I redraw this pulley at this position, so if this pulley moved by a distance x, so this strand of the rope x and this strand of the rope x must move this mass in the 2x distance in the downward direction. So this is how we establish a constraint relation between the motion of the two blocks 2m and m. So I can say that if the acceleration of 2m block is a towards right, then the acceleration of m in the downward direction will be equal to 2a from constraint analysis. Now the next thing which we come for is the direction of tensional force. So if a tensional force is acting on this rope in this direction, so eventually over here the tension force is going to become 2t. So now if I draw FBD of each block individually, so for 2m I can draw the FBD in this way, that a mass of 2 mg is acting in the downward direction, which is balanced by the normal reaction force in the upward direction. A force of 2t by the spring is exerted in this direction, and as a result of which the mass is accelerating with an acceleration a. If I draw FBD for the block M, so it is going to be in this way, that the block M is going to exert a force mg in the downward direction. A tensional force T is acting in the upward direction, and it is accelerating with an acceleration of 2a in the downward direction. So if we write the Newton's law equation for both the masses, so I can write it in this way. For 2m mass, it can be written as 2t is equal to 2ma, and from here we establish a relation that t is equal to ma. This becomes the first equation that we have. For the mass m, I can write that a force mg is acting in the downward direction, a tensional force T is acting in the upward direction, and m multiplied by 2a. So from here I can say that T is equal to ma, and the net equation which we have is equal to 2ma plus ma. So we will get something like this: mg is equal to 3ma and acceleration is equal to g by 3 meter per second square. So from this portion we can say that acceleration of mass capital M is going to be twice of a. So acceleration of mass M is going to be twice of a, so it will become 2g by 3 in the downward direction. The next question that is asked is the tension in the spring. So tension in the spring is going to be equal to ma, so we can write it as mg by 3. So tension in the spring will become mg by 3. Now the next question that is asked is calculate the force exerted by the clamp on the pulley A in the figure. So the clamp which is exerting on the pulley A is asked. So if I draw this in this fashion, I can draw this diagram like this. For the pulley A, if we consider this as pulley A, so I am saying that there is a tensional force T in this direction acting in the pulley A, another tensional force T in this direction on the pulley, and there is an R1 that is the resultant of the tension force that is acting in this direction by the clamp on the pulley. So I can say that the reaction force R is equal to root over T square plus T square, which is equal to root 2T. And if we calculate the value of root 2T, so we get the value equal to root 2 times of mg by 3 by putting the value of tension from the previous problem. And since both the tensions are equal, so I say that the force will act at an angle of 45 degrees. So this is the force which is exerted by the clamp on the pulley.